Continuation of that one, no? That is Karl Pearson coefficient of problem we have to do. We already discussed that. We will start the problems based on that concept. Now we will do the problem. Find the coefficient of correlation between two variables. So x and y values has been given to us, and for that the answer is x. I have written it as x values, y values. Capital X equal to x minus x bar. Y is equal to y minus y bar, where x bar and y bar are averages of the given two series, a capital X square, y capital Y square, and the capital XY. Next, coefficient correlation coefficient equal to summation of xy by square root of summation of x square into summation of y square. Or another formula is also there. Some coefficient of correlation coefficient is equal to summation of xy minus summation of x into summation of y by n by square root of summation of x square into summation of x whole square by n into square root of summation of y whole square minus summation of y whole square by n. The value, substituting these values, we get the value as 0.7512. Next, another problem. With the following data in 6 series, calculate the coefficient of correlation by Pearson's method between the density of population and death rate. Cities has been given area in square kilometers, population in thousand, number of deaths. So answer for this one, density is equal to population by area, death rate is equal to number of deaths by population. Here we have calculated the values and have framed a table, density as x value and death rate as y values. So density is equal to 200, 500, 400, 700, 600 and 300. That is population by area. Population by area. That means 30,000 by 150, 90,000 by 180, 180, like that. If you calculate it, you will get the density. And the death rate is number of deaths by population. Here, number of deaths by population. 300 by number of deaths by population. Yes, that is death rate. Now, XY values here. XY values, that means here death rate is 300 by 30, 1440 by 90, 560 by 40, 840 by 42. Like that we did. Now again another table, XY and capital X equal to x minus x bar. X bar is a summation of x value. 2700 by 6 is the number of numbers has been given to us. Y equal to y minus capital Y equal to y minus y bar. Capital X square, capital Y square, capital XY. After finding all these values, coefficient of variation is equal to summation of xy by square root of summation of x square into summation of y square. We got the value as 0.988. Next, when deviations are taken from assumed means. Just now we did a problem based on mean we have calculated. Now next is assumed means. If assumed means has been given, how to find out? When actual mean is not a whole number but a fraction, when the series is large, the calculation by direct method will involve a lot of time. To avoid such tedious calculations, we can use assumed mean. Formula for this one, almost all it is same for that one. But here we have to find out the capital X as x minus a, capital Y as y minus a, and summation of xy. Total the product of deviations of x and y series from the assumed means, and capital of x summation of x square. Total of squares of the deviations of x series from assumed means, summation of y square. That means total of the squares of the deviations of y series from assumed means, summation of capital X, total of the deviations of x series from assumed means, total summation of y, capital Y, total value, total of the deviations of y series from the assumed means. Now we will go through a problem based on this concept. Find out the Karl Pearson coefficient for the following data. height in further inches, that we consider it as x, and the height of the sun in inches as y. The value has been given here. X bar and y bar are assumed means. X bar equal to 67 and y bar equal to 68. This is assumed means. X bar is 67, y bar is 68. This is, I told you, in the previous problems, if 8 has been given, we can take fourth one or fifth one as an assumed means. So n is the number of observations. Small x, capital X equal to x minus x bar, x square, y, capital Y equal to y minus y bar, y square, xy. Coefficient of correlation formula has been given from the previous, which we have discussed, and substituted. We got the value as 0.472. Next, another problem. The problem table gives the distribution of total population and those who are taking totally and partially blind among them. Find out if there is any relation between age and blindness. So age has been given as a class interval, number of persons and blind persons. Answer for this one, Anna? We have to find out the number of blinds out of a fixed number. That is, we find the number of blind persons corresponding to 1 lakh in each age group. So first value 55 by 1 lakh, you will get into 1 lakh equal to 55. Second value 40 by 60,000. 40 by 60,000 into 1 lakh is 67. Like that, we have to do each and every value, so that you will get the values. The values are 55, 67, 100, 111, 150, 200, 300, 500. Right. A table has been generated. Age, mid values, x is equal to m minus 45. This 45 is assumed mean. By 10 is a class interval, x square. Blind per lakh has been, which is calculated in this format. The values has been tabulated here. Y square, xy, capital Y equal to y minus a. Here assumed mean. Nana. So x bar and y bar are assumed means. X bar is equal to 45 and y bar is equal to 180. We have taken here as an assumed mean. Next, correlation, coefficient of correlation, the formula which we have discussed. Substituting the values, we get the coefficient of correlation is 0.898. And a small problem has been given here. Given n is equal to 10, coefficient of correlation of x, row of standard deviation of x series 5.4, standard deviation of y series is 6.2, and sum of the product of deviations from the mean and mean of x and y is 66. Find the correlation coefficient. So here, given that has been mentioned here, and in this, the formula which we have used, rho x square equal to 1 by n into summation of x minus x bar whole square. So according to that, 55.4 whole square equal to 1 by 10 into 1 by 10 into summation of x minus x bar whole square. So this term comes to left hand side. Consider this one as equation 1. Similarly for y, rho y square is equal to 1 by n into summation of y minus y bar whole square. 6.2 whole square equal to 1 by 10 into summation of y minus y bar whole square. And bringing this 10 to left hand side, you will get the equation as second equation. And from the equation 1 and 2, and they given summation of x into x bar and y into y bar is 66. So that is considered as third equation. From that, coefficient of correlation equal to summation of x minus x bar into y minus y bar by square root of summation of x minus x bar whole square into summation of y minus y bar whole square. We got the value coefficient of correlation R is equal to 0.1971. Next is rank correlation. This is the most important topic which we have to learn in this topic, that is in this correlation. What is meant by this? The small introduction has been given here. This method is based on rank and is useful in dealing with the qualitative characteristics. What are the qualitative characteristics? Means morality, character, beautiness, intelligence, all these and all. It cannot be measured quantitatively as in case of Karl Pearson's coefficient of correlation. So this is used for the only comparison of beauty contest. Like that it is used, and honesty in that situation, rank correlation is used. The formula for Spearman's rank correlation. Spearman is the scientist which has been developed, which has been discovered this one. So he has generated this one. The formula for Spearman's rank correlation is given by rho is equal to 1 minus 6 into summation of d square by Kaplan into n square minus 1, where rho is the rank coefficient of correlation, d square, sum of the squares of the difference of two ranks, Kaplan, number of paired observations. Now properties of rank correlation coefficient. Always the values lies between +1 and -1. If the value is equal to +1, there is a complete agreement in the order if the ranks and directions of the rank is same. If it is the value is -1, then there is a complete disagreement in the order of the ranks and they are in opposite direction. Now we will do a problem here. The ranks of 16 students in mathematics and statistics are given here in ordered page. Calculate the rank correlation coefficient for proficiencies of their group in mathematics and statistics. So here mathematics and statistics. Now a table has been given. Ranks already has been given here. That's why we have tabulated directly ranks in maths as X, ranks in statistics as Y. So ranks has been mentioned here according to the ordered page, and D is equal to X minus Y. Capital D square also has been calculated. Summation of D equal to 0. Summation of D square equal to 136. Rank correlation coefficient is equal to 1 minus 6 into summation of D square by n into n square minus 1. The value is 0.8. And another problem has been given. 10 competitors in a musical test were ranked. Here I have taken three types. That means three participants. 10 competitors in a musical test were ranked by 3 judges A, B, C. The ranks has been given in the tabulated form. Using rank correlation method, discuss which pair of judges has the nearest approach to common linkings in music. Now, as an answer, 3 ranks has been here. I have mentioned here, and D equal to difference between X minus Y, D1. D2 equal to difference between X minus Z ranks, and D3 is the rank between Y and Z. D1 square, D2 square, and D3 square has been mentioned here, and the summation of that one also has been taken. Summation of that one also has been taken. And in the next rank correlation between X and Y. Rank correlation between X and Y is 1 minus 6 into summation of D1 square by n into n square minus 1. The value is minus 7 by 33. And second rank correlation between X and Z. The value is 7 by 17. Third rank correlation between Y and Z is minus 49 by 165. So the calculation, since second rank correlation between X and Z is maximum, we conclude that pair of judges A and C has the nearest approach to common links in music. The next one, now based on ranks we have told. Now, if any 2 ranks, that means ranks are repeated. In that situation, what we have to do is the next concept. So that is equal or repeated ranks. If any of 2 or more persons are bracketed equal in a class classification or high same rank is repeated, then Spearman's formula is not at all possible for us. In that situation, the average of the ranks of which items would be assumed if they are different to each other, and the next rank has to allocate it to them. That means if 2 individuals are placed in the 7th place, 2 ranks has been given as 7, 7. So each what we have to do, 7 7 plus 7 and 8. We have to take 7th place and 8th place by 2, 7.5. So, each has to give rank as 7.5 and 7.5. The next rank go for 8, not 8. It is as 9. Actually, 7 and 8th ranks has to be given, but the values are same. That's why what we have to do is 7 plus 8 by 2, 7.5. We have to give the rank as 7.5 rank, 7.5 ranks, and the next rank is not 8. We have to go for 9. Why? Because this 7, 8 has been segregated, has been splitted it as 7.5 and 7.5. For that formula, if two individuals are placed in the 7th place, each of them are given in the 7.5 and the next rank will be 9. So then the formula for that one is 1 minus 6 into summation of d square into d square plus 1 by 12 into m cube minus m plus 1 by 12 into m cube minus m. This here m is how many repeated values has been given, that one. That is m1 square minus m1, m2 square minus m2 cube minus m2. Like that we have to take by n square n cube minus n, where m is equal to the number of items where ranks are common. So a problem has been made based on this concept. Please go through here. A sample of 12 fathers and their elder sons gave the following data about their elder sons. Calculate the coefficient of rank correlation. So fathers and sons data has been given. Fathers we consider as xi, their sons we consider as yi, ranks of xi, ranks of yi. Here if you observe, first rank is 71, second rank, that means based on the value, second rank is 17, and third rank is 69, and fourth rank 67, fourth rank is here 68, and 68 2 are there, 68 2 are there. So what I did, according to procedure, what we have to do is fourth and fifth position we have to take average 4 plus 5 by 2, 4.5, 4.5. That's why I have given 4.5, 4.5 for 4 and 5 positions. Next is sixth position. Again, here in the sixth position, 67 has been repeated. So 6 and 7 positions, average is 6.5, 6.5 has been given. Next is eighth position I have taken directly. No 6 and 7 positions appearing here. I have taken average of that one. So like that, we have to do in place of y ranks also. Di is equal to xi minus yi, di square. So here I mentioned repeated values are given common rank, which is the mean of the ranks which we got, and x series 68 67 has been appeared here. In the same way, y also we have 68 in x series has to occupy 4th and 5th rank. Since 68 has been repeated, we assign the rank average 4 and 5 as 4.5, and the next rank is 6. Again, 67 is the x series has been occupied 6th and 7th position. So average of that was 6 plus 7 by 2 is 6.5 for both, and the next rank is 8. Like that we have discussed it. Similarly in the y case also. So correction factor in the x series is 2 into 2 square minus 12 by 12 plus 2 into 2 square minus 1 by 12 is equal to 1. Similarly for y series also there, if you calculate the correction factor, you will get the value as 6. Now rank correlation coefficient is equal to 1 minus 6 into summation of d square into 1 by 12 into m1 1 by 12 into m1 m2 cube minus m2 plus again 1 by 12 into m into d m square minus m. Like that we have calculated according to the formula. The value which we got it is 0.712. Next, another problem has been given here. So the problem is the difference between the ranks are has been mentioned here. 0.5 minus 6 minus 4.5 minus 3 minus 5 minus 1 3 0 5 5.5 0 minus 0.5 for refracted ranks. That means ranks has been mentioned, x and y. Summation of m into m square minus 1 by 12 value is 3.5, and rank correlation coefficient here is 0.44. Find the number of terms. Here, difference has been given. That we consider as di. Next is di square, and the summation of di square has also been mentioned here. So, according to the formula, rank correlation coefficient is equal to 1 minus 6 into summation of di square plus summation of m into m square minus 1 by 12 by n square minus n. So after substituting the values, given values, we will get n is equal to 42. The next concept is a regression. Next concept is a regression. So first of all, we will go through the what is meant by a regression and types of regressions. Next, we will go through a few problems in this concept. First of all, regression. The study of correlation measures the direction and strength of the relationship between the variables. In correlation, we can estimate the value of one variable if the another variable has been given. That we have, that till now we have gone through in the correlation. Now regression means here one value they will give, then we have to find out the other value. In regression, we can estimate the value of one variable with the value of the other variable which is known. The statistical method which helps us to estimate the unknown value in one variable from the unknown value of the related variable is what is called as regression. The line described in the average relationship between the variables is known as line of regression. So uses for that one, it is used to estimate the relation between two economic variables. It is a highly variable tool in economics and business. It is widely used for production purpose. We can calculate coefficient of correlation and coefficient of determination with the help of a regression coefficient. It is useful in statistical estimation of demand curves, supply curves, etc. Next, comparison between correlation and regression. Comparison between correlation and regression. Correlation is a measure of covariability between two variables, while the regression is a functional relation between dependent and independent variables. In correlation, both the values x and y are random variables, whereas in regression, x is a random variable, y is a fixed variable. The coefficient of correlation is a relative measure, whereas for regression coefficient is an absolute figure. So methods of studying regression: graphical method, algebraic method. And first one is graphical method. In this method, points represented the pair of values of an unknown of variables are plotted on a graph. The independent variable is taken on x-axis and dependent variable on y-axis. These points form a scattered diagram. A regression line is drawn between these points by freehand. That is as a graph we are doing generally. That is the graphical method. Next comes to algebraic method. The regression line is a straight line fitted to the data by the method of least square. It indicates the best possible mean value of one variable corresponding to the mean value of other. There are two regression lines, that is a regression on x upon y and a regression of y on x. Next, least squares curve fitting procedure. Generally, in the fitting of a straight line, we will use as a, in your next semester, that means in second year, first semester, you will come across many problems based on these least squares. Here we have gone through only fitting of a straight line, but there we will come across fitting of a straight line, second degree equation, that is parabolic equation, power curve, exponential curve, all curves. But here as a basic, we are learning only fitting of a straight line. So there, for fitting of a straight line, what we have to require is the normal equations. The normal equations are summation of y equal to m into a naught plus a into x. Summation of xy equal to a naught into summation of x plus a1 into summation of x square. Number of values we consider it as m. Next is regression equation. Regression equation is an algebraic expression of the regression line. It is classified into regression equation, regression coefficient, individual observation, and group discussion. The standard form of the regression equation is y equal to ax plus b, where a and b are constant. It is also called as regression coefficient of y on x, and x equal to a plus by is a regression coefficient of x on y. Next is deviation taken from arithmetic mean of x on y. This method is easy when compared to the previous method. A regression equation of x on y is x minus x bar is equal to rho into rho x bar coefficient into rho x by rho y into y minus y bar, where x bar is the mean of x series and y bar is the mean of y series. The regression coefficient of x on y, bxy, is equal to correlation coefficient into rho x by rho y, that is equal to summation of xy by summation of y square, where x equal to x minus x bar, y equal to y minus y bar. Regression coefficient of y on x, byx, rho into that is rank correlation into rho y by rho x is equal to summation of xy by summation of x square, where x equal to x minus x bar, y equal to y minus y bar. Y minus x bar and y bar are means, and rank of correlation square is equal to bxy into byx. Result in the regression line always pass through the point x bar comma y bar. If two regression lines of y on x and x on y are a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, then a1 b2 minus a1 b2 is less than a2 b1. Now problems based on this concept. For the following data, find the equations of the two regression lines. X and y table has been given here. So answer for this one, capital X, capital Y. X means x minus x bar, x square, y minus y bar, y square, xy. X bar is mean of that values. X bar is equal to summation of x by n. Summation of y is equal to y bar is equal to summation of y by n. Byx and bxy. Regression equation of y on x is given by y minus y bar is equal to byx into x minus x bar. Regression equation of regression equation of x on y is given by x minus x bar is equal to bxy into y minus y bar. This is the regression lines. Next, another problem. In the following table, S is the weight of potassium bromide, which will dissolve in 100 grams of water at V degrees centigrade. Fit a equation of the form S is equal to m plus Tv by the method of least square. Use this relation to estimate S is equal to estimate S when T equal to 50 degrees. A table having T and S values has been given here. T and as an answer, T is equal, T values has been mentioned, and dt is equal to T minus 40. T minus 40. This 40 is assumed value, assumed value T minus 40 by 10, and dt square, yes, ds minus s is ds is equal to s minus 75. 75 is the assumed mean here by 10 ds square dt into ds. M is equal to summation of dt into ds by summation of dt square. B is given by the equation summation of s is equal to m into summation of t plus nb. Here n is the values, 5 values has been given, that is n. So 375 is equal to 0.52 into 200 plus 5b. The value of b, we got it as 54.2. They have told another one, if t equal to 50 degrees, what is s value? S value is 80.2. So next problem given to us is determine the equation of straight line which best fits the data. X and y value has been given to us. So in a table, x and y values has been given to us. So answer for this one, x and y values has been given to us. So the straight line equation y is equal to a plus bx. Here capital N is number of observations that has been given it as 7. The two normal equations are summation of y equal to b into summation of x plus na, summation of xy equal to b into summation of x square plus A into summation of x. Here, x table has been generated, x square, y, xy. And the summation of the values also has been calculated. Substituting the values in the normal equations. Just now we have discussed the normal equation. By solving, we get the values of a and b. So the equation of straight line is y equal to a plus bx, that is 0.82 plus 1.56 into x.